Okay, so welcome back. Hope you all had a wonderful weekend. Today we've got our lesson dedicated to just recapping our first test. Okay, so for the next 6 lessons, we'll basically be recapping one test per lesson. So our very first test was on chapter 2, specifically differential calculus. Okay, so it was just the rules of calculus. So if we've got our notes books there, we've got the sheet that we've provided you with, okay, so the formula sheet there with all of the formulas and notes on it. And then over the page, we have the content from the textbook. So we went from 2A through to 2I. And what we will do today together is we'll work over a few of these questions, and then I'll open up the floor for you guys and point to a few places where you should dedicate your efforts to cover these skills in particular. Remember, we will have time to address everything. We're just going to go through the course very methodically, starting at the start with differential calculus. Okay, we want to get those skills down pat. So, any questions about that before we begin? Excellent. All right, so we'll start with 2A, first principles. All right, so we're using first principles to find the derivative function. So the formula for first principles is f dash of x is the limit as h approaches 0 of 1 on h multiplied by f of x plus h, take f of x. Okay, we've got a nice easy one to begin with. We're just doing a quadratic equation there. Y equals x squared plus 2x. So feel free to use this space alongside to solve it. I reckon there will be enough space there to perform all of these derivatives as we go. Okay, so the function that we have is y equals x squared plus 2x. Okay, that's the function that we're starting with. So when we put it into the formula for first principles, we're going to have 1 on h multiplied by f of x plus h. So we're putting x plus h everywhere there's an x. Okay, so f of x plus h. Take away f of x. So then we have to take away the function. Now with first principles, you cannot overuse brackets. So I mean like use brackets everywhere that they should go. So we have f of x plus h, that's the first function, take away f of x, and the reason that's imperative is because we're taking away the whole thing, this negative needs to distribute. Alright, we'll process that. So first principles, like what's the step? Put it in the formula, expand, collect like terms, cancel h, apply limit. Alright, always the same. So we have a perfect square here. So x squared and x squared will cancel, 2x and 2x will cancel. And remember, everything that we have left over should have a h in it because we want to factorize and cancel h. So that's a bit of a checkpoint. That's a way to see if we're on the right track. We can see all of these terms have a h, so we can factorize and cancel the h. So we'll have h. And we've got 2x plus h plus 2, that will cancel, and then we can apply our limit. So we're basically subbing 0 in where the h is, which gives us 2x plus 2. Alright, and we can check that using simple differentiation. The derivative of this function is 2x plus 2. So first principles, they don't pop up in every exam, but they're common enough to warrant us covering it. I would say between a third and half of exams have a first principles question in them. Okay, very good. Then we'll move on to simple differentiation. So with simple differentiation, we've basically got 3 rules. If we have x to the n, the derivative is nx to the n take 1. Okay, that's the most common one. If we have kx, the derivative is k. And the derivative of a constant is 0. So we're basically using all 3 of those in this exercise. And so the one we're starting with then is we have 3x plus 2x squared, y equals 3x plus 2x squared on top of x squared. Okay, that's the function that we want to differentiate. Now, we can't just go ahead and perform the power rule because we have a numerator and a denominator. We have to simplify this expression. So what we're going to do is split the denominator. So we're starting with a tricky one. Okay, split the denominator. Now we can simplify each term. The top one here is going to become 3x to the minus 1. All right, we're doing the top power, take the bottom power. And this one's just going to simplify to 2. X squared, x to the power of 2, take 2, x to the power of 0. So, index laws, simplification. All right, I'm making an assumption we're pretty competent with those skills at this stage. If you have questions about how we've moved from there to there, please ask me. Okay, now notice we've got y equals. Okay, this is still the function, and we need to be very specific about this is the function, and now it's in a form ready for us to differentiate. It's at the top of the function, fraction, everything's expressed as x to the power of n. So now we differentiate all in one step. Okay, equals, equals, equals. Now we have something different. The derivative of y with regards to x. And all we're doing is the power rule. X to the minus 1 goes to minus x to the minus 2. And the derivative of a constant is 0. So we don't need to consider that term. This is the derivative function. Now there are multiple ways of arranging it. Remember, we always say, just like the exam, differentiate without simplifying. Okay, so you don't need to simplify that. The only time you simplify is when it says show that the derivative is this. So you do have to manipulate it in that circumstance. Most circumstances you don't. In the in the textbook, they simplify almost everything. All right, so what have they done for something like this? They'll take the x to the bottom and express it as squared at the bottom, and then there's a negative hanging out the front. Okay, so that's the way we can express it as a fraction with positive index powers. All right, both of these mean the same thing. You get 4 marks here. Very good. All right, so now we'll move on to the chain rule. Okay, so that's 2b. Now we'll move on to 2c, where we're doing the chain rule. And I'll just talk about the chain rule quickly. When we have a composite function, we have some function to the power of n, then the derivative is n f of x to the n take 1 times f dash of x. Okay, that's the chain rule. So the function that we've got then, we have y equals x squared take 3x to the power of 5. Okay, so we have a function to the power of 5, and so we're just going to follow this rule through here. So it's going to become 5 times the function to the power of 5 take 1, which is 4. So n f of x, n take 1, and then multiplied by the derivative of the inside here, 2x take away 3. So n f of x, n take 1 times f dash of x. 4 marks there. Okay, then I've listed both the product rule and the quotient rule. I haven't got an example for them, but they're just continuing on from our power rule, and then they include things like derivatives of exponentials and logarithms. So we'll go through to 2f, where we have derivatives of exponentials. Just to refresh you on that rule, if we have e to the f of x, then the derivative is f dash of x, e to the f of x. So in our circumstance here for 2f, we have y equals 2e to the 3x plus 4. All right, so we can look at that and go, we've got e to the power of a function. Remember that number, that's just going to hang out. It's multiplying. It's not a constant by itself, it's multiplying. So when we differentiate, and we can do so in one step, all right, make sure we have dy on dx here. That's a little bit of a slip up. We've gone from y to dy on dx. Okay, the 2 is going to hang out, and we have e to the f of x. All right, e to the f of x goes to f dash of x, e to the f of x. So e to the 3x plus 4 is going to go to 3 All right, the derivative of 3x plus 4 is 3, e to the 3x plus 4. All right, we could simplify that by expanding that. That's fine at this stage. Okay, logarithms. So for 2g, we have log of 2x to the 3, take away 4. Now the rule for a logarithm is if we have ln of f of x, it just goes to f dash of x on top of f of x. So it's quite an easy one for us to differentiate. So that means if this is y, then the derivative is just going to have the denominator being 2x to the 3 take 4. Okay, we just have whatever's in brackets goes at the bottom, ln of f of x, and then the derivative of what's in brackets goes at the top. So that's going to be 6x squared, and the derivative of 4, that goes to 0, so the derivative of what's in the brackets here is just 6x squared. Alright, so that's trig, and we got one more. Alright, do that one up here. Cos of 2x. Okay, now all of your rules, guys, they're just listed here on this page, so you can refer straight there. Maybe we'll do that. So if we've got cos of kx, or cos of f of x, alright, minus f dash of x sine of f of x. So for 2g, cos of 2x and y equals, and we can differentiate in one step. dy and dx is minus f dash of x, so minus the derivative of 2x is 2, so there's our minus f dash of x, and then multiplied by sine f of x. Okay, so all we're doing in this unit, right, is rules of calculus, okay? So basically, I think the key takeaway is make sure we know how to differentiate. Every single question 1 of the exam for the past 20 years has had differentiate without simplifying, okay? At least 2 of them, sometimes 3. So the rules are important, all right? So I'll just spin this around and I'll just point out where you can dedicate your efforts. So I just wrote here. So we've got lots of tests for you to have a look at that focus on these skills, okay? You've got the review sets from chapter 2. That's a good sort of broad summary that brings all the stuff together, mixed up together. Another thing you might do is work through your notes booklet, okay? Because I've got lots of problems in your notes booklet. So I'm very happy for you to just look at those questions and try those out again. In extra resources, there's a PowerPoint called Which Rule, and that just takes you through some jumbled up calculus problems where you have to decide which rule to use to solve them. There's a Kahoot, maybe we can do that a bit later today as a class. And there's a First Principles extra worksheet, okay, for questions dedicated specifically to First Principles. So we've done a recap of what we've done in Chapter 2. Now it's up to you where you're going to dedicate this time, focusing specifically on just Chapter 2. Remember, we're going to address lots of other stuff in lessons to come in anticipation of the exam. So any questions about that? Cool. All right, so let's get started. You guys